All right, hello everyone. This is 4.1 day 3, looking at polynomials using our graphing calculator. So we're going to jump right into the notes here. So go ahead, turn your calculator on, and we're going to go ahead and put this equation right into our calculator. So go to y equals, and just start typing x to the third plus 2.48x squared minus 4.3155x plus 2.484406. Press enter. And now to get just a regular window, we're going to zoom into 6, and that'll give us a standard 10 by 10 window. And we'll see this graph come in. So as you can see, we kind of missed part of our graph. So I'm going to adjust my y scale. So I'm going to go to window, and I'm going to make my y max a little bit bigger. I'm going to go to 25. And that was just a guess at 25, but we do see the whole graph now, so I'm good with that. And let's just go ahead and sketch this in right now. And we'll fill in some information as we go. So, first things first, this polynomial is in standard form because the exponents are going down, 3 to 2 to 1 to 0. So it is in standard form, so the degree is 3. And the end behavior is based on that third degree polynomial, that leading coefficient, which is x cubed. So I'm down and up. All right, so my left-hand side is down, right-hand side is up. Right off the bat, I could also give my domain and range. My domain, I'm going to keep going down and to the left, and then going up and to the right. So my domain is all real numbers, and my range is all real numbers as well. Now, I'm going to use my calculator to get some of these important points. So if I go to second calc, I can find my 0. My 0 is an x-intercept, so I'm going to hone in on this point. It says left bound, so I'm just going to go left, 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 left. And so I'm left of that 0, press enter. Then I'm going to go to the right of the 0, press enter, and then you can guess and press enter. And so I get this point to be negative 3.79. Comma. It says negative 12e to the, negative 2e to the negative 12. That e to the negative 12, that's scientific notation. So that means times 10 to the negative 12th. So that'd be 12 zeros before, it'd be 0.0 with 12 zeros, then 2. So that's such a small number. It's basically 0. It's just a calculator isn't exactly confident in 0, but we're going to say it's 0 because it is 12 decimal points, so it is 0. So that's my x-intercept. Right. I can also find my local maxes and mins. I'm going to go second calc, and I'm going to go to a maximum. All right, so I'm going to hone in on this maximum, or this maximum right here. So again, I'm going to stay to the left of it, press enter. Now I'm going to go to the right of it, press enter, and guess. So I get a maximum. So it is a local max. It's a local max because it's not the absolute highest point or lowest point, right? There's obviously values larger than it, but it is a local max. So second calc, go to min. So the calculator sets for a local and an absolute max and min are the exact same. So min, left bound, right bound, and in the middle. So I get this minimum occurs at 630, comma 1. So I have a local min at 0.630, comma 1. All right. So that's my x-intercept, max, min. To find my y-intercept, right, this value right here. Well, my y-intercept happens at when x is 0. So if I have an x value, I can go second calc again, and I have an x value. Press enter, and I plug in what that x value is, which is 0 here, and it gives me the y-intercept of 2.48. All right. I could also know that it is always my last value, that constant value, in standard form of a polynomial. So there's my y-intercept. The other thing you could do on the calculator, if you're interested to see other x values, you can go to second graph or second table, and this will now show you a bunch of x values from negatives, all the steps of 1, so 0, so -4, -3, -2, -1. It shows us all the integer values. So that could be something that you're interested in as well. But that's using your calculator to graph and find important features about your graph.